This conference will now be recorded.
Okay, so what we have discussed in the last session.
TCP header, IP header.
IP header and
And
MAC address.
method,
Difference between MAC address
methods
and IP
like
address.
Yeah.
and methods like unicast, multicast, broadcast.
So we have discussed the TCP versus UDP and the TCP header, how the TCP header looks, and how does the UDP header looks, and what are the various applications where the TCP will be using and where the UDP will be using. We have discussed. So along with that, so we also discussed. So what is the IP address and what is a MAC address? So IP address is something. So in order to route the traffic over the internet, over the network. Okay, so any system here wanted to communicate internet resource. Okay, so you must need an IP address. So your system need an identification. So that is the internet protocol. In short, we can call as IP, internet protocol address. So you must need an IP address in order to communicate with the following, with the internet resources. So whatever the internet resource, it might be a Google, Facebook, Yahoo, or whatever the resources you want to communicate. So you must have an IP address. Okay. And what about the MAC address? So MAC address is
It having own unique physical address to specify itself exactly located where it is located IP.
Yeah. So IP tells you that so in the internet, in the network, where is your computer is located. Okay. But physically, so for example, so if the IP is there, so where in the internet, Google can exactly know where your computer, in which network it is there. But again, the MAC comes into your picture. So which physical device, where exactly the device has been. So IP address will continuously changes, but the MAC will not change. So MAC is the one. So whenever any internet resource is trying to communicate you, so first it will identify on which network it is there. So based on the IP address. So exactly want to route the traffic to or send a packet data to the computer. So you must need a MAC address. MAC address is something physical address of the device where exactly the mission is there. So it's like your identity. It's everyone. So like for us, how we have a unique identity, right? So everybody have their unique identity by the names. So mostly most of the people don't have a unique same names. Everybody have the same unique names. At least their surnames will changes, right? So my name is something Narendra. So somebody have the name of same name, but they should not uh, the same surname. You cannot find mostly. Okay, you cannot find it all with my surname and with my name. So nobody can maybe in the world somewhere one or two people may be there, but in terms of the missions, the MAC address is unique. So whenever the computer itself manufacturing itself, they will create a one MAC address for your device. So that's an IP address and MAC. So medium access control. So internet protocol address. So we have seen. So how does what are the types of IP addresses? So we have IPv4 and IPv6. Okay, IP versions. So IP versions are IPv4 and IPv6. So IPv4 can be represented in a 4 octets. Okay, so 4 octets in the sense we represent 4 octets. Further, if you study the digital electronics, most probably you'll be aware of it. So 1 octet is equal to, see, 1 byte is equal to 8 bits, right? Same way, 1 octet is equal to
8 bits.
is a 8-bit representation. Okay, 8-bit representation means, so here we have the 4 octets, right? For each octet is a so 4 octets. This is a 1 octet, and this is a 1 octet, 1 octet. So like that. So each octet contains a 8 bits. So if you take how the 8 bits, how the 8 bits, this is the starting value. This is the starting value of uh, this is starting value, and the last value will be all ones. Okay, this is how this is the binary. We have to represent in a decimal format. All zeros means 0. Okay, now all ones are there. How many ones are there? 8, right? That means it will be represented as a 2 power 8. What is the 2 power 8 value? 256. But we are starting from 0, right? You should not write as a 256. You have to write as a 255. If you start from 1, it should be 256. But you are starting from where? All zeros. So that's why 0 to 255. Okay. So what you have to remember is, okay, so 4 octets, right? So each octet will be, first value will be 0. Okay, first value will be 0. So now how many octets we have? 4 octets. 0 dot 0 dot 0. Right. So 4 octets we have. Okay. First octets start from 0. All zeros means 0. Second octet also the same. All zeros. The first value will be 0. Third octet also. What is the first value? 0 0. All the zeros. Fourth also 0 0. Now come to the first octet. So what is the last value? 255. Again, what is the last value? 255. Again, what is the last one? So this says that, so you can write IP addresses from 0.0.0.0 to 255.255.255.255. Okay. So start from 0.0.0. First IP. What is the first IP? 1. 0.0.0.2. Like how many IP addresses we can write? Till 255. Then after that it starts from 0.0.1 dot 0 again. This is 0.0.1 dot 1, 0.0.0 dot 1 dot 2 up to 1.255. Again what happens? This value become 2, and this till how many? 255. Again this value 3, 255. So like that it keep on reaching. So that's how you can IP. That many means we have almost, how many combinations of IP addresses we can write is 3 million, like these combinations. Till 255 we can write. This is the range between 0 to 250. This many IP addresses are possible. So yeah, it was a little confusion, I'm sure, because if you are not aware of the digital electronics, the binary values and decimal numbers, it will be confused. Okay, so if you guys are studied engineering, in an engineering, you will find it out, or even I don't know in degree whether you may find it or not. So this is the bytes and bits. Okay, if you have to know about it, but yeah, it's okay if you're not aware. Yeah, let's leave this. Got it? So in short, we can write, okay, IP addresses. Okay, again, this IP addresses has been classified into 5 classes. Okay, so the total 0.0.0.0, right? This is the decimal value. If you write the same thing in a binary value, just imagine what is the binary value if you write the same decimal value into a binary. So what is the value? This 0. What is the value? Like this.
110000.
So 0 means all 0 zeros. So if 1 means it will be all ones. Again 0 means 0, like this.
Yes.
So don't confuse it. This was little tricky thing. Okay. So anyway, what you have to remember right now, what you have to remember is IP addresses has been classified into IPv4 5 classes. Class A, B, C, D, and E. Right? Class A. Okay. So what are the IP addresses? 0.0.0.0.02 in between 255.255.255.255. So this is the range. Between this range, we have divided into 5 classes of IP address. The first value start from 0 to 0.0.0.0 to 126.255.255.255. Okay, that is the range. In short, we can call it as a 0 to 126 is a class A. Okay, even we can remember like this. So these values are always the last 3 values are same from the both the sides. So this is always start with the 0 and this is always end with the 255. Now class B. So 128 it starts. 127 is the 127.0.0 is a completely for the loopback address. We'll discuss about this later. So right now, so 127 is completely for the loopback, and 128 it starts from 128 to 191. Okay, 128 means 0.0, right? And the last value is always 255, 255, 255. Again, class C start from 192 to 223. Class D 224 to 239. So always this value is a 0. The last value will be 255. Okay, and right here in a proper way. Class A 0 to 126. Class B 128 to 191. 192 to 223. Class D means 224 to 239. Class C means 240 to 255. Got it? So what is this meaning? So if the IP address between 0 to 0.02 126.255.255.255. Got it? So in between this range IP address is class A. Class A. So now tell me, I will write one IP. Okay. So 86.29.255.250. So what is the What is the class of this IP address?
Class A.
Yes.
So the same way, this one also the same. 128.0.0 to 191 dot. Last IP address is 255.250. The same way, 192 from 0, 0. So remember, you have to keep that. And 223, 255, 254. So like that. 224, 0.0. 220, 239.255. So like this. So now tell me, I will write one IP address. Just let me know what exactly this IP. So 192.168.0.10. So what is this IP? What is the class of this IP address?
Class C.
Yeah. So that's how the classes will be represented. So whatever I told, that just an information. So for if you have that, if you know how do we write an IP address. So like 4 octets we have to represent. Each octet is 8 bits. So that's why 8 bits mean 2 power 8. That means 256. First value of 2 power 0, right? So we will be starting. What is the 2 power very first value? 0. That's why we are writing from 0 to 256. So 0 to 256. Okay, don't confuse again. So again, if you have confusion, just leave that confusion and just remember these classes of IP addresses. Okay, if you want to understand more and just going through again, just have a gone through this class again, and once again you just go through you'll find it out some sort of calculations, all these things are. Fine. So and now again, so we have the private IP and public IP address. We have a private. We have the private and public IP address. The same classes only. In that only the till 0 to 0.0.0.2 till 255 has been classified into has been divided into classes in the same time. So a couple of IPs will be private, couple of IPs will be the public IP ranges. So let me tell you. So here, what is the private IP? So if you are working in an organization, so if you are working for one company, so and this is the internet. Okay, this is the internet and your company. So your internet. So you always communicating to the internet via public IP. That means, so you have some Wi-Fi router. Okay, so you purchased from some Geo or whatever BSNL or Geo or whatever the service provider. You took a internet connection. Means you took an internet connection means you purchased the what we call it as a you purchased a one public IP address. So now what happens when you're trying to communicate this device? This is the host 3 is trying to communicate to the internet via the public IP, which is given by the ISP. Okay, so but see here, so these are the 3 computers, right? So these are the 3 computers you have. So inside of your computers there will be you will be using the private IP. You will be using the private IP, and this one have a private IP1 and private IP2, and this is the private IP3. So this is the internet. And so whenever your system, any of the system is connecting to internet, okay, so any of the system is trying to connect the internet, so it must use this one public IP address. So whatever the ISP given a public IP address, so all these 3 systems will use the same public IP address and will be reaching to the internet. So one single public IP address. Okay. At the same time, internet also sending a data. So internet sending a data reply packet to you means your router, and your router receives that, or your whatever the device will receive based on the MAC address. Okay, based on the based on the private IP and MAC address it will send. So ignore right now here the MAC. Based on the private IP only it will identify the host. Okay, where exactly the inside your system. Got it? So it's like your internet cannot see your inside IP. Okay, another way, tell another way. Private is a private IP address is something which is configured internally to your computer. Okay, but the public IP address is something. So you wanted to access. So you wanted to access the internet. So you must using the your service provider will be given a one public IP address which will be your use. So for example, I will show you. So here. So what you are seeing here is an IP address. This is the private IP address. So this is the whenever I connect it to the internet also. So this is the private IP address I have. So this is the IP address I have, my LAN IP address. Correct. So this is what you are seeing, right? Now let me see what is my computer. I can see here what is my IP address. What I am seeing here is the public IP address. So you can also find the details about this IP address. We'll get it where exactly yesterday also we discussed. So where exactly the IP belongs to also, because right now I'm using ACT Wi-Fi router. So probably you can see the same info here as well. So here see you can see ACT ACT Technologies. So ACT Technologies you will be able to see, and it is belongs to India, right? So that's how you can find out more details. So see here the location also I got it where exactly I'm using, and broadband internet service provider. So that is the public. When you see here, this is the private address. So you cannot see the information about this IP address. For example, if I tried, so now I'll try here the same IP address. Let's see what happens. For example, I paste the same IP address. So you cannot find any information. This shows a private IP address. So you cannot get any information like here. What is that? Where is exactly? So this is a private IP address. You cannot find any information. So the same way here also I'll try. So private IP address, the data you cannot see, like where exactly it is and to whom it is belongs to, all these things you cannot find. See, IP address is not a valid. You can see that IP address is not a valid because this is the private IP address. So let's see what is the ranges of public and means for internet public IP address where you so what is the range and private IP address range. So we have a 5 classes, right? Like a 0 to 127, 128, like till 255 we have a different IP addresses are there, right? So let's see here. So here what you are seeing here is this is the class. So this is the private IP address. So this is the private IP address range. So all this 10 series. So whenever the IP, if you see any of the IP with a 10 series, so that is the private IP. So you can use only inside. You cannot use outside. So for example, you have a LAN. So within in your organization. So in your organization, if you see the LAN, so all the IPs within this range, or all the IPs in this range. So whenever you have 100 systems in your local area network and you wanted to communicate your local area network devices, you must assign this private IP address. So this is the range you have to remember. So 10 series is completely the private IP address, and 172.16 to 172.31.255. From 16 to 31 is the private IP address, and 192.168 to 255. This is a also private IP address range. Okay, this is completely private IP address range. So when you see public IP, other than this IP address, other than this private IP range, so I'm seeing here the 10 complete 10 series is private. So then 8 series is completely private, sorry, public. 7 is public, 6 is public, so like that. So other than anything which is not falls under this range, even 172.16, okay, to till 172.31. So now tell me, so 172, I'll write 172.15.0.0 is a private or public? Yes. So at the same time, then 172.32.255, 32 dot, yeah. So this is it, which is not falls under in this range. Even the complete 168 series, 192 168 series, okay, so falls under. So the complete 192 168 series will be in the private IP address range. So other than, if you go 192.169, then it will be public IP address. So make sure you have to remember this. This is very important. This is very, very important. Classes of IP address and ranges of private IP range and public IP ranges. So private IP is something you are inside. Internally, you're configuring your system with a private IP address. So we'll better explain in another way, in another example. Okay, right now what is that? Private IP address is only inside an organization. So when you have 100 systems, you should not give 100 systems of the public. You should not have a public IP address. You should have a IP address range within the private IP address range. So, and when you wanted to communicate over the internet, okay, you must purchase a public IP. You need to purchase a public IP. From where? From where you have to purchase? In a where you are purchasing the IP, public IP address. So where you are purchasing? See, right now private IP is okay. Where you are purchasing, or where your where you will get the public IP address? Huh? Sorry.
I have to use some commands now. Previously, I used the IP configuration and IF configuration.
No. See, public IP address means, yeah, you have to. Public IP address is something you have to interact with the internet. So interact with the internet means whom? See, for example, I wanted to interact with the internet, so I must enable the data, right? Enable the data, or I should have some internet. I should have some Wi-Fi router or something I should have. So otherwise I cannot reach out to the internet, right? So means you have to take a, if you want again, so you wanted to reach the internet means you should need a Wi-Fi router, or your mobile should have enabled internet. That means you're purchasing, when the data is enabled for you, if your data is loaded, your mobile is loaded with a data, your mobile is loaded with a data recharge, or Wi-Fi router. If you enable, if you buy and if you enable your Wi-Fi internet, then only you will be getting a internet, means your public IP will be there and it will be connected to the internet. That's a purchasing. Well, that purchasing means connecting. So connect, you're buying the internet connection, means you're purchasing one public IP address, so from the internet service provider. Okay, so that is the public IP address. Okay, so now, so we will be jumping into the protocols. So we're gonna see the next 1 or 2 days will be completely, we'll discuss on the protocols. So what are the protocols we have?
HTTP,
Yeah, so we'll discuss with the DHCP is the first protocol. Okay, so the DHCP is the first protocol. So that I can relate to this DHCP concept with the IP addresses as well. So the DHCP is a server, which is what is the DHCP is dynamic host configuration protocol. Okay, this is the server which is responsible for, the server is responsible for assigning an IP address to your devices in the network. Okay, let me understand. So how does the server works? So if I have an organization, I have started a new company called as XY Z. So now, so I have started a company with 100 systems. Okay, so all these 100 systems must be connected with a single LAN. So all are in a single LAN. So I wanted to enable the communication between these devices. So I must need a IP address. I must need IP address, right? So these two has to communicate, or any of the devices, or over the internet also. If I want to communicate, or so anything, so wherever, it must need the computer must need an IP address. Without an IP address, you cannot communicate any of the device over the network. Got it? Now, what I have to do is, so there will be 100 systems. So usually the organization have a one system administrator. Okay, one IT support or IT admin, or IT support or a system admin. So they will come and they will assign the IP address, subnet mask, and the gateway details. These are the network configuration details you have to do for every system. So just imagine if there was 100 systems. So at least for each and one system, it takes at least 5 to 10 minutes to assign the IP address. And you have any of the companies, the people, very few people, 1 or 2 or 3 people will be there for a shift. So what he has to do, he has to go each and every system, assign the IP address. So for example, there will be 2 people, and there will be 100 systems. So each guy will be doing a 50 systems, 50 into 5. 50 it should be 5, or we have to restart the system. So just think about it, 500 minutes. 500 minutes means how many hours? Okay, so just imagine how many minutes, how many hours it will be. 500 minutes means. Okay, probably 500 by 60. Okay, so it will be almost 8 hours, 8 to 9 hours. So it is a difficult task. Okay, like that. So it will be spending 8 hours of time for us spending to giving an IP address and everything. So it was a mostly it was a if the guy was a one person is doing, just imagine if the guy was one person was doing, it will take a more time. So that's why there was a protocol, there was a one server, DHCP server, which is DHCP server, which will be responsible for DHCP server. What is this? Dynamically configuring your host. Dynamically configuring your host with the IP address. So within a seconds, so once you connect your device to the internet itself, your sorry, not your internet, it will connect to the network. For example, I am a new employee and I have connected to a company. The company has given me a laptop and I have connected to the company network. So immediately, so I'll be assigned an IP address. How does it is happen? Because of once if I connect to the company network, so automatically I'll be allocating an IP address. So how does it is happen? We will see. So who is responsible? DHCP server is responsible for assigning the IP address to your computer. Now, how does the DHCP server will assign an IP address to your whenever a computer request a, so this is your computer, and which is there are a couple of devices are there. Okay, sorry, this is the DHCP. This is a DHCP server. Now the computer is whenever you connect it to the internet, sorry, whenever you connect to the network, so whatever it is your company network, so immediately it sends a one broadcast packet. Okay, broadcast means what is a broadcast packet? Broadcast is something everybody will receive the packet. So what it will do is it sends a packet saying, asking that, hey, who is responsible for assigning the IP address to me. So it is started discovering means it is trying to find out the, we can say it as it is trying to find out the where exactly the DHCP server is located in the internet, sorry, in the network, in the company network. Okay, that is called as a discovery. So the discovery will be the broadcast. Broadcast means this discovery packet will reach all the computers in the network. Every computer will receive, but only the DHCP server. How does the DHCP server will identify? Based on the port number. So port number is something 67. Okay, then the DHCP server, oh yeah, I am responsible for this service. How does it DHCP server will identify? Based on the port number. Remaining all other computer will reject this packet. Okay, everybody receives. So here I have some HTTP web server is there. I have another server is there. Filed FTP server is there. So HTTP web server cannot understand the DHCP port number. So that's why it will reject. Here also it will reject. It will go here. It will reject. It will go here. It will reject all this. Only the DHCP server will respond. So the very first packet is discovery packet, and so the discovery packet will be sent by your computer to your DHCP Then the DHCP server, hey, I am responsible for this service. So okay, and it offers a pool of IP address. So now right now your system doesn't have any IP address. So it offers a pool of IP address. That is, so okay, I have this IP. For example, I have the 10.0.0.5 IP address is there. Okay, so and network configuration information, the default gateway, all the other network configuration information also there. So now your DHCP server will offer this IP address along with other network configuration. Okay, and your computer, yes, I want this IP address. Please assign this IP address. So it will send a request to you again, whatever it is offered. Okay, and once it is offered, your computer will request to please provide the same, and the DHCP server will finally will assign the IP. Let me explain in a better way. So your computer and your DHCP server. Okay, the first, it sends a broadcast packet to everyone. Okay, this is the broadcast packet. So a lot of other FTP and other web page, web application servers and everything. So what it will do, this is a broadcast packet. So this is called a broadcast. Okay, now everyone will reject. Only this one is accept. This is a discovery packet. Now this is the first one. Okay, these are also first. The second packet will be, second is your server, DHCP server, have a pool of IP address, which it will offer to your computer. So this is called as offer. Okay, discover. Okay, offer. Then your computer C1 will send a third packet to your DHCP server saying that, okay, so yes, please provide it will request your DHCP server, request you to please provide a same IP address to me with the other network configuration details. Then the fourth packet will be whatever it is offered in the earlier, and it was saying yes, it will assign finally in the fourth page, it will assign the IP address to your computer. So whatever the requested IP, it may be 10.0.0.5. So it will assign the same IP address to you. Okay. Discovery phase, offer. Discover is a broadcast packet. Okay, offer. So DHCP server will offer to you an IP address, and the third packet will be you're requesting a DHCP server to assign the same IP address. Okay, and finally it is last phase, DHCP server will be assigning the IP address. So the whole phase, we can call it as this process, we can call it as a DORA process. DORA means discover, offer. So discovery phase, your computer will be sending. Offer phase, DHCP server. DHCP server will be initiating client mission. Client is you and the DHCP server, and then you will be requesting a IP address, that is the client mission, and assigning. So A for assigning. So finally the DHCP server will assign the IP address. This is called as a DORA process. DORA. Discover, offer, request, and assign. Got it? Discovery phase, identify where exactly the DHCP server. So once the DHCP server will identify here, I am the service, then the DHCP will respond to you with the IP address along with other network configuration details, and so your computer will get that IP address details and will get the info, and then told to the DHCP server to assign that IP address, and DHCP server will acknowledge that and assign the IP address to your system. So the finally your system have the IP address and your system start communicating with the other devices. So this the whole process is happens in the fractions of seconds. It's not even a second, or it will be less than second. The whole process is happen within a seconds, very seconds of fractions of seconds. So that's why that is the DHCP protocol. So the DHCP protocol have the port number of 67 and 68. So 68 is for the broadcast and 67 is for unicast. Okay, got it. Now the very first packet is the discovery packet, that is the broadcast with the port number of 68, and remaining all other are unicast. So IP exchanging, IP assigning, okay, pool of offer of IP address and everything will be unicast. It's a one-to-one communication between your computer and the DHCP server. Got it?
Yes.
Okay, any questions here?
Sir, for all the system, the same process will be happen, right?
Yeah, the same process. So whenever means internal systems like
Yeah.
yeah. So every time, so there will be even if you so whenever you connect it to the organization network, for example, so the organization servers also organization network have the DHCP servers, and they will be assigning the IP address to your computer. The same way, anytime, like even internet also, if you're connecting to the internet also, so there will be a process of assigning the IP address to your system.
Okay. Actually, it means while discovering, it will be under broadcast packet.
Yeah,
No? While
broadcast.
after discovering, while it is assigning, so it is comes under unicast.
Yeah.
Okay.
So assigning phase, so it will it is not offering. So discover offer phase. So in the offer phase, the DHCP server contains all the IP addresses, all the private IP addresses, whatever we have seen, right? Private IP address ranges. So that all the private IP addresses ranges will be holding by the DHCP server. So once it will offer an IP address to your computer, and your computer will acknowledge and will request your DHCP server. Everything is unicast again. Last three are unicast. So a request, assign, discover, offer, request, assign. So DORA process we call it as. This is very important. Discover, offer, request, assign. So no more questions. So the port number is very important here. 67 and 60.
The port number is to be a constant, right?
For every port protocol, the port number is constant, same number for every. See, for example, there was right now I told you the protocol is DHCP. The
Yeah.
DHCP will be identified based on the port number. The port number is same every time. Whenever, see, for example, if say, how can you say, the port number is something which is the service identification, what type of service it is providing, right? Okay, if you go to the postal office, so what type of service you will get? Courier service you will get. If you go to the hospital, you will get a what type of service you will get. What type of service you'll be getting? Some medical issues if you have. So then you'll get a medical service to you. If you go to the hospitals and if you ask for the postal service, okay, what they will say, they will give you. So that's why. So the service also here also. So DHCP server will be providing a DHCP server, and the service will be identified by the server based on the port numbers. Okay. So here the port number is for example, I'm sending source port is so destination port is something 68 means, oh yeah, this service is something DHCP service. So one of your computer is trying to request for a DHCP server. Okay. If the port number is something 20, so then it is looking for a, if your computer is looking for a FTP service. Okay, the service is, every service there will be a one specific, means every protocol they have the particular port number. So it will be same for any service, means different services, different service numbers will be there. Like, see, for example, if you are in a city, and if the 500 buses will be something in the in the city, 500 buses in a Bangalore will identify as it will go
Yeah.
Silk Board, right? The same way here, the protocols numbers will says that what type of service it is, what type of service it will be giving to your whatever service. That's also, it's just a service identification. That's all. So we'll start with the tomorrow. The tomorrow we will be starting with other protocols. So those are the lengthy protocols. So at least it takes at least half an hour, 20 to half an hour it takes for each protocol. So we'll go with the DNS. DNS concept is a very big concept, and the hierarchies. So you have to understand the complete hierarchy and how does the DNS. Okay. So the next concept will be the DNS, and then after there will be SMTP, FTP. Okay, and so we'll discuss these other important protocols which will be which will be using in our security environment. Okay. So yeah, so we'll wind up the session today, and so what we can do is yeah, so probably I'll have a call tomorrow as well in the morning. So what I'll do is, so Wednesday, Thursday, and Friday we will connect on the evening times. Remaining all other days we'll connect on the morning itself. Okay. So any concerns you have on this timings? Only Thursday, Friday we will connect on a we'll connect on a 4 o'clock.
Fine, sir.
Okay, fine.
So yeah, and one more. So I have done the profile updation for Prasad, both the Prasads and Hemant. So I'll upload those CVs into Naukri today, and so tomorrow morning onwards, or I'll intimate today evening itself. Probably I'll complete by 7-8 o'clock. What you guys have to do, once, just go to the Naukri and go to the search option. So just type Security Operations Center SOC and then apply the jobs. So you have to, whatever it is. It may be expired jobs also. It may be a recent one also. It may be a 4+, 5+ years also. or whatever the company, don't look at all those things. Just go and apply it. That's all. So just go and apply it for to make sure